Hello, everyone, and welcome. My name is Reid, and I will be your instructor tonight. Hope everyone's having a wonderful, wonderful evening. A couple things before we dive in. Just want to start off by saying thank you. Thank you so much for taking time out of your day to learn, right? You could be doing anything else, but you have decided to put some effort in and continue to grow your understanding of pretty intense JavaScript and programming concepts. So again, you should be really, really, really proud of yourselves because that is a really amazing thing to do. So let's dive in. Let's talk about classes, prototypes, and object-oriented programming. Now, just to raise a hand here, you could do a physical raise of your hand. You could do a raise hand emoji. That's fine too. Who here has been to this hard parts before? You've been to OOP, you've been to classes hard parts before. Okay, Rye, Renee, Lily, Gary. Okay, actually a good number of you. That's really fantastic to see. Well, welcome back. People, please take note of how many individuals raise their hand. Here's my next question for you. Raise your hand if you've been to a hard parts, but not this hard parts. So maybe you've been to recursion or closure, but you haven't been to classes in OOP yet. Okay. Well, shout out to you for deciding, again, a lot of you. This is nice. We see, that means there's a lot of familiarity with this process, which is fantastic. Shout out to you for deciding to learn something new and continuing to level up. Well done. Now, my last question, raise your hand if this is your first hard parts. You've never been to a Codesmith hard parts before a day in your life. This is your first time. Jay, Sunjin, Jason. Oh my God. Wow, amazing. I think we just have a lot of people in the room as well. 82 people, fantastic. Well, shout out to all of you, seriously. You should be, again, so proud of taking this leap, keeping in mind that this is a safe space. And the thing I wanted you all to understand when I asked these questions is firstly just to see kind of who's been through this before. But in addition, take note that what we're going to go over tonight is some tough stuff. This is going to be some advanced JavaScript. Seriously, like I would probably argue that, and I will argue it, you're actually going to see me talk about that on a slide at some point, that a lot of JavaScript developers who've been working JavaScript for a while have no idea under the hood what we're going to go over tonight that you're going to know by the end of this evening. But because this is difficult stuff, you got to be kind to yourself. And you got to keep in mind, you're probably going to need to come back to this workshop multiple times. Maybe a different instructor helps you click. But if you take away 30% today, and then next time you come back, you might take away then 40%, then 50%, right? Just know that it's going to take time. So don't stress if you're like, whoa, where are we going? This is insane. Like we're taking big leaps here. Ask questions, but again, be kind to yourself. Because keep in mind, there was a lot of people who have been to this hard parts before, and they are back, and that is extremely normal. So just a reminder on that. Okay, here we go. I'm going to just lower some hands. Okay. Now, classes, prototypes, and object-oriented programming. This is an enormously popular paradigm for structuring our complex code. OOP is not a JavaScript specific thing. It is not a coding itself specific thing. It is a coding paradigm. It is a way you can structure your code to make it easier to utilize, to grow, to scale, to absorb for other developers to see. So object-oriented programming, I would say probably one of the two biggest programming paradigms. You may have heard of object-oriented programming, OOP. You may have heard of functional programming, another pretty popular programming paradigm. Again, as I mentioned, well, why do we even do this? Well, it makes it easy to add features and functionality. And you're going to see that through tonight's example. It makes it easier to, as you're developing an application, as you're developing a project, if you decide you want to make changes or grow certain functionality, well, OOP makes it easier to do that. It is performant, especially in terms of memory. I feel like as you continue to develop your coding skills and your knowledge, usually memory is not the first place your mind goes for optimizations. It's usually maybe speed or time, things of that nature. And by all means, absolutely, that makes sense. But don't sleep on space. Don't sleep on space. You want to be memory efficient, okay? And it is easier for us and other developers to reason about. It presents a clear structure. At the minimum, it presents, because it's a programming paradigm, a set of rules, okay? A path to follow so we can see kind of where our code is going and how it's grown and how we can utilize maybe that new functionality. Now, before we dive into the kind of first initial step of OOP, we just need to get kind of a common language together. Now, again, a lot of you have been to a hard parts before. A lot of you are new. So let's kind of go over some initial basics here. So we see a little code snippet on the right here that's going to kind of touch on most of the things in this kind of foundational level of vocabulary. Now, let me ask you, let's start with, let's go with Laura Glass. I think it says Johnston at the end. It's cut off for me. But Laura, I'm going to ask you a question here. So let's say we're coding. Let's say we want to take like a set of instructions. We want to bundle those instructions up. And then later on, we're going to want to run those instructions, perform those instructions. What do we call that bundle? What do we call that bundling of step-by-step instructions?
Function. Function.
Yeah, a function definition. Exactly. The two pieces come together, and we're definitely going to use that vocabulary of function definition. But you are spot on. The first part I want everyone to be very aware of tonight, and thank you so much, Laura. The first thing I want everyone to be very aware of tonight is what a function is, because we're going to be using functions a lot, and they're going to come really into play in tonight's hard parts. And a function is that entire piece right there. Okay. Laura mentioned function definition. Which is exactly correct. We're going to talk about that on the next slide. But for now, functions. Okay. Now, software development really comes down, in a way, really to two pieces. Kind of two things all software development comes down to. One is storing data. Okay. Storing data in memory. And the other piece is running functionality on said data. So I'm going to say that again. This is really software engineering in a nutshell. Storing data in memory and running functionality on said data. Well, we got our functions. I know I kind of said it already, but Nico, okay? What are we going to call kind of the space on our board, in our program, that we're going to store data? What do we call that, Nico?
Memory.
We call that memory. Exactly. Well done. So we have functions, we have memory. Again, something that's really going to come into play in tonight's hard parts. Now, there's another piece we need to talk about. There's really two more. We're going to talk about this next one. JavaScript is what's known as a single-threaded language. It can do only one thing at a time. Not all languages are like this. Some languages are what's called multi-threaded. They can do multiple things at the same time, but not JavaScript. JavaScript is single-threaded, one thing at a time. And there are trade-offs to that. There are pros and cons, but one of the pros for sure is It allows us as JavaScript developers to keep track of exactly what our JavaScript engine is doing. And JavaScript, it's kind of like English. It is top down, left to right. Top down, left, right. And JavaScript, kind of like when like you're a kid, when you're a little kid and you're first kind of learning how to read more than just letters, like you're really starting to read like books, like you're diving into your like Magic Treehouse books. I'm bringing up some books from my past. So Magic Treehouse, I guess it's technically Berenstain Bears. We all said Berenstein and you know it, and that's okay, because it was Berenstein Bears, all right? You're first kind of putting together those words. You kind of like took your finger, you kind of started at the top left, and you worked letter by letter. You kind of connected the words then connected to make sentences, sentences connected to make paragraphs, right? Well, JavaScript kind of does a similar thing, and it has a tool it utilizes to keep track of that. Let's see here. Jeremy Holland. I'm sorry, I'm going to try to say last names because there might be a couple of Jeremys. Jeremy Holland. Do you remember what the name of that kind of tool is? What we call that?
Is that the thread of execution?
It is exactly correct, Jeremy. Very well done. That is called the thread of execution. The thread of execution. Now, people at Codesmith, sometimes, in fact, a lot of the time, we will abbreviate the thread of execution to TOE, T-O-E, thread of execution. But if you go out into the real world and you're interviewing and you're saying the TOE, when you're talking about the thread of execution, you're going to get some really weird looks. So here, safe space to call the thread of execution the TOE, even though I think it's more like the finger. I guess it's depending on how you read. You could read like a really, unique way, and then maybe it's the TOE. But the thread of execution, this is JavaScript's way of kind of knowing where it's running its code and what it's looking at. And that's going to come into play tonight as well. There's one last piece I want to chat about, but I think I'm going to move on to that when we get into the next slide. Okay, so just some basic understanding, some foundational vocabulary for us for this evening. Now, what are we going to do tonight? Well, for those that have not been to this hard parts before, it's unique in that tonight we're going to be building a game. We're building a game. And it's going to be a quiz game. And it's going to be with users. And let's see, the game will be for tonight. Let's see, whose game will it be? Let's go with Joanna. Joanna, it gets to be your game. This evening, we're going to be building Joanna's quiz game. Now, there are some basics we all know this quiz game needs to have. Well, firstly, we're going to need maybe something like a name. Okay. We need to know who our users are, what their names are. We're going to maybe keep track of a score. Great. Right? We're competitive. I want to crush this quiz game. But maybe later on, we're going to want to add some things like the ability to increase a score or decrease a score. Maybe delete a user or log in a user. Maybe add an avatar, add a picture, get the score, or whatever else you want to do. But here's the thing, when you're developing a game or you're really developing anything, you're not going to know all the functionality. In fact, you shouldn't want to use all the functionality in your initial building of that game, of that application. You want to start small and then go big. Okay? Now, tonight we're going to really be building this idea of encapsulation. That's going to be our goal. Beyond just building this quiz game, we want to build a quiz game utilizing encapsulation. And encapsulation is the enclosing or the combination of data and functionality. So, Joanna, it's your game. I'm going to ask you a question. And again, safe space. So, supportive space here. In JavaScript and in coding in general, but in JavaScript, there is a called a data type. There's a way that, that is built particularly well to store both data like numbers or strings like names or, Booleans, true or false, as well as functions. Do you know what that data type might be, Joanna?
It's an object.
It's an object. Wow. Well done, Joanna. And this is going to be we're going to say object a million times tonight, but object is exactly correct. Objects are perfect because they allow you to store, again, data like numbers, strings, Booleans. You could store things like null, undefined. You could store other objects. You could store arrays, but you can also store functions. And Jordan, I'm going to ask you a follow-up question. Do you know there's a term we use when we are talking about a function in an object? Do you know what that term is called?
It's a method.
It's a method. Okay. So Joanna set us up beautifully with this idea of we're going to be talking about objects because objects are a great way to head towards encapsulation. And whenever you hear the term method, all it means, never panic. All it means is it's just a function in an object that's defined in an object. We just say method just to make it clear it's a function in an object. Okay? Awesome. Now, in Joanna's game, we're going to be using objects a lot. In fact, every user in this game is going to need to be stored at some type of a user object. To start tonight's exercise, we're going to try to go through 3 different ways that we can create objects and store information inside of them. Now, before we dive into that, I need to set up my board. So for those that have been here before or been to a hard parts, you're going to be familiar with this. For those that are new, just pay attention because you're going to see how kind of the board will be utilized and the space on the board will be utilized as we diagram and go deep into object-oriented programming and classes and prototypes. So first things first, we kind of mentioned this earlier, but let's go with Jason P in Phoenix. There is, again, a place that I'm going to need to store information. And for those that don't know, when we initially kind of run our code, we are in what's called the global space. So Jason P, if we're in the global space, if you want to take a guess, what do we call the space where we are going to store data?
Global memory?
Global memory. Exactly correct. I'm going to stick with you as we kind of work through this board a bit because you're crushing it already. You're a victim of your own success. So I'm going to keep calling on you. All right. So we're going to basically, let's say I'll make for now. By the way, thank God this app turns lines into straight lines for you. That would be tough. Okay. So this area we'll call global memory. So everything in here, that's memory. That's what we'll be storing information. Got it? Now, Jason, we're also going to be needing an area where we're going to be running our code. When we're in the global space, do you know what we call that area where we run our code?
Is it the global execution context?
It sure is. It sure is. So this area will be called the global execution context. So kind of, pretty much the whole space here. Jason, another thing we're going to need, we kind of talked about a little bit about it before. What do we call the tool JavaScript utilizes to keep track of kind of where it is in terms of, word by word, letter by letter, keywords, etc.? Oh, you're muted.
Oh, sorry. Yeah, I don't know the answer.
All good. I'll give you a hint. We could go back a bit. Take a look here. It's on this screen. Do you remember it was kind of like JavaScript's finger, but it wasn't the finger?
Oh, in the thread of execution, the toe?
The thread of execution. Exactly correct, Jason. So I'm going to be kind of diagramming the thread of execution with this green arrow. So you see green arrow, that's, me representing the thread of execution. Now, Jason, I did not go over this. So if you don't know it, that's okay. If you don't know some of the other things, that'd be okay. But if you don't know this, that's fine. JavaScript also utilizes a data structure in order to kind of keep track of what we call our stack frames. This is kind of which execution context is JavaScript currently running its code. Do you know what we call that data structure that keeps track of these stack frames?
I don't know.
That's okay. This is a tough one. This is a really advanced one. I'm going to have, let's see, Ian Weinholz. You want to assist here?
The call stack?
The call stack, exactly correct. Well done, Ian. Thank you for the assist. Jason, excellent job as well. By the way, people, throughout tonight, show love in the chat for everyone who's participating because everyone's crushing it, okay? So we're going to utilize the call stack. Now, in tonight's workshop, the call stack is not going to be really the focus. You might see that more in like recursion and some of our other workshops, async for sure. But it's still important to note. So the call stack, let me make this a little bit cleaner. Is a structure that consists of stack frames. And stack frames are just areas for JavaScript to execute its code, to scope information, to keep track of data. We always begin with the global stack frame on the call stack. That's just whenever you run your code, just to start, you always begin in the global space, the most outer space. The most outer space. Yeah. So, but not outer space, but the most outer space. So we start in global. We're going to start adding and taking away stack frames a little bit. It's not going to be, again, a lot that we're doing tonight, but Ian, I'm going to stick with you just while I got you. There is a technical term we use when we add a stack frame onto the call stack. Do you know what we call the term for adding a stack frame?
Pushing.
Pushing. That is a technical term, people. We push a stack frame on, but when we're done with the stack frame, when we're done with an execution context, we take off the stack frame. Do you know what we call, Ian, removing a stack frame?
Popping.
Popping.
Pop.
That's exactly correct. That's exactly it. We push stack frames on, we pop stack frames off. And call stacks are what's known as the last in, first out data structure, or LIFO. I've heard LIFO. I like LIFO more, but you get to choose, dealer's choice. Last in, first out. So what does that mean? The analogy I always use is a stack of pancakes, right? You're making pancakes. It's already a wonderful day because that's happening. And you put the batter together. You got a plate on the side. You got the griddle going. You pour a little batter. And these are big pancakes. You're not putting like little dollar. No, this pancake's as big as the griddle. Okay, that's how hard we're going on pancakes this morning. Okay, so you're making your pancakes. You finish your first pancake. You put it on the plate. Now you go make your second pancake. Put the second pancake on. When you're done with the second pancake, it goes on top of the first pancake. Keep it going, third pancake. When you're done with the third pancake, it goes on top of the second pancake. So on and so forth till you build this pancake stack. Now you're done cooking the pancakes, it's time to eat. And in this analogy, this is how it should work. You're not sifting through the middle of the pancakes. No, the way it works is whatever pancake's at the top, the last pancake you made is actually the first pancake you take off to eat. Okay? It's the same idea with the call stack. Whatever stack frame's at the top, that is where your thread of execution is currently running code. So if you're ever lost in terms of which execution context am I in, look at the call stack, because whatever stack frame's at the top is where your thread is. Okay? Also, a thing about this analogy is it made me realize that the last pancake you eat was also the oldest pancake you made. Kind of like a little sad if you think about it, but it is what it is. It is what it is. Okay, So let's do it. We have built the system, our board for this evening. So now we can really dive into the code. Again, we're going to go over 3 ways to make objects. So let's start with the first way. And hopefully you should be familiar with these kind of concepts. If you're not, it's okay, follow along. So with this, I'm just going to call on anyone, whether they've been here before or not. So let's actually go with Lily Mueller. I'm going to have you start on line 1. And again, safe space, trying to use that good technical communication. But going on line 1, kind of walk me through what you think's going on there.
We're declaring a constant with the label user1.
Mm-hmm.
And we're setting it equal to or instantiating it to an object literal.
Beautiful. And because we are starting in the global space, where do you think we're going to store this?
In the global memory.
Amazing. So just like Lily said, we're declaring constant variable user1, and we're assigning it an object literal. Okay, keep it going, Lily.
Let's see, and since it's just an object literal, then we just go down to line 2.
Mm-hmm.
Where we're giving it a property or a key called name,
Mm-hmm.
and instantiating that to the string will.
Okay.
And then we're giving it another property called score and setting that equal to the number 3.
Okay.
And then another property called increment. And the value of that is a function.
Beautiful. And I'll get to the exact terminology we're going to use. In fact, actually, let's do it now. So Lily did a great job and said that increment is a function, and it is a function. But what we're going to say here while we are assigning and saving functions in memory is, and I believe Laura mentioned it earlier, is that we are going to be storing the function definition. So what does that mean? The function definition is all the information between the orange parentheses that I just drew. When you store a function in memory, and let's say it has a label, right? Right now we're calling, we have a key increment and we're assigning it a function. But what we're really doing is we're assigning it the information between those orange parentheses. Sometimes when we declare a function, we say like function multiplied by 2. Well, multiplied by 2 is the label. The value at multiplied by 2 is everything in the orange parentheses, the function definition. So we're just going to say we're assigning to increment a function definition, okay? Now, the way that we here at Codesmith diagram a function definition is going to be a box with an F in it and an arrow, a fancy F and an arrow. Essentially, if you were to ask me why exactly this, I don't think I could ever tell you because the person before me did it like this and the person before them did it like this. But I'm just going to say, I think it means, a function in a direction. The thread is going to eventually maybe move through this function. Okay. So if you see increment is now a function definition in memory. So Lily, we were on line 4. What line do we go to next? Or JavaScript goes to next?
Line 8.
Exactly. And so what made you, and you were correct. What made you know that you didn't go to like line 5?
Because we haven't actually called the function yet.
Spot on. People, this is really important. When you declare a function and you have all those, lines of instructions in the function body, JavaScript does not enter your function and start running that code. No. It stores that information in memory and it goes to whatever line is after the end of that function declaration, right? JavaScript does not enter that function and run code until we invoke it, until we call it. So like Lily said, technically I think it goes to line 7, but we're done. We've created the object and we're done here, right? Then we go to line 8. So JavaScript never even went to line 5. It stored all that information in memory. We're on line 8. Lily, could you just, using, again, the great, wonderful technical communication you have so far, what does line 8 say? What's going on there?
Scrolled up, but I think it was just invoking the increment function on user 1.
Amazing. Exactly correct, right? And so we can see, like, we're looking at line 8 here. And by the way, if I need to scroll around, just let me know, because sometimes I can see it on my screen, but it can't be seen on yours. So just always let me know. But on line 8, user1.increment, the same idea, right? This is what JavaScript does. It goes, okay, I see user 1. Is there a user 1? Cool, there is in memory. The dot tells me that I'm looking at some type of property. Increment, okay. Is there a property called increment? Yes. And then these parentheses. These parentheses at the end of a keyword typically, or a variable name typically, means run. Run a function stored at that variable name. So it's saying, go to user 1, great. Is there a variable name called increment, a key increment? Yes. Is its value a function definition? Yes. Great. Let's go run some code. Now, people, for those that have been here before, you know what we're about to do, because we just invoked the function. For those that are new, take note, because you're going to be like, what's going on? Why is this so crazy? For those that have been here before, unmute. You know what's happening. We have invoked a function. So we are creating a new
execution
context.
Nice. I typically feel like the first all together is like around a 3, and then we build from there. I'd say this was like around maybe a 5 or a 6. So I have really high expectations for where we're going to end up. Okay. So you set the bar high. So what did everyone say? For those who are like, I heard 20 people at different times say something jumbly. They all said a new local execution context. Local execution context. When we invoke a function, JavaScript opens up a new kind of space in memory in order to run that code. Okay. So I'm going to open up a new local execution context. And because I'm a developer, I'm lazy. I've already built a picture to do this. I'm sorry, I'm not sorry, okay? Just not. So we just invoked increment. So I'll put this kind of whole piece here. Let's copy that. Okay. Now, Lily, thank you so much for all the setup. Excellent job. Very well done. We're going to now move into the actual running of the function. Let's go with Renee. Okay. We have, and again, if this is new, like no stress, we'll walk through this together, but we've invoked a function. So before we go run stuff in this local execution context, we need to do some work with the call stack. Do you have any idea of maybe what we need to do there?
Yes, we need to push the increment, onto the call stack.
Exactly. So we're going to push the increment stack frame onto the call stack. Beautiful. So now that increment's at the top, what needs to enter that local execution context?
The thread of execution.
Exactly. Okay. What happens next?
The next thing we'll do is go into the function body, and it is telling us to increment the score property in the user1 object.
Exactly. So let me just put that in here. Okay. Now, Renee, let me ask you. It says, like you said, it's going to try to increment the score property on the user1 object. Where is JavaScript first going to go look for user1?
Local memory.
Okay. Does it see user1 in local memory?
No.
Nope. Right? We never declared user1 in local memory. That's not where it exists. Because it's not in its local memory, where does it look next?
Global memory.
Okay, and does it see a user one there?
Yes.
Sure does. And what does it do?
Looks inside the object to find a score property, and it finds it.
And then what?
And then we increment it from 3 to 4.
Exactly. We increment it, and just for those that don't know, the plus plus means increment by 1. So it was a 3, it's now a 4. Renee, we're done, right? This function, there's nothing left to do. We have to do some cleanup. So what's some of the cleanup we now need to do?
So we rep the local execution context for garbage collection. We move the thread of execution back to the global execution context, and we pop increments off the call stack.
Exactly. We pop this off. So increments no longer on there. Amazing, amazing job, Renee. Very well done. Great technical communication. Let's go over just some of the terms that Renee used so everyone's on the same page here. Renee had said, first we need to, prep or make eligible. I hear often as well, this local execution context, make it eligible for garbage collection. So what's that? That is a technical term, garbage collection, okay? And that is essentially the removal of information from memory, right? To allocate more space to be utilized later on when we, if we're not using this space and memory anymore, we got to get rid of it. Now, in JavaScript, certain languages are very explicit about how garbage collection works. Like you got to tell your coding engine, remove this from memory. JavaScript is not like that. JavaScript is a very forgiving language, meaning it takes a lot of the nitty-gritty detailed work off of your hands. For better or for worse, everything's a trade-off. Now, the process of removal is called garbage collection. In JavaScript, if you have data that's either been marked for deletion or data with nothing pointing to it, meaning there's no variable, nothing, no pointer to this information, this is what we call an orphaned data. Orphaned data. It's a terribly sad term, but it just means there's nothing pointing to this information anymore. And JavaScript under the hood knows, it just has a system. When it was built within the JavaScript engine, it knows that at some point in your running of your code, the JavaScript engine will go through and grab all the information either marked for deletion or that's been orphaned and garbage collect it, remove it from memory. But when exactly that happens, we don't need to worry about. All you need to worry about is if we mark it for garbage collection, just know we can't use it anymore. There's no being like, actually, wait, come back. No, it's gone. So just keep that in mind. If we say it's eligible for garbage collection, it's gone. Okay, that's all we need to care about. Renee also mentioned the thread returns back to global, which it does because we pop the increment stack frame, right? We're done with this local execution context, which means we pop the stack frame off and the thread returns to whatever stack frame's at the top. What's the only stack frame? I mean, it's at the bottom, but it's also at the top. It's global. So it returns back out to global. Cool? Okay. That was the first way to make an object. I think a pretty traditional way to make an object. Let's try a second way. This way. Okay. Let's go to, I know you're new, but I'm excited for you to participate. Sunjin Kim. Okay.
Hi.
Hello. Thank you so much for joining us. So tonight we're going to go over now our second way of making objects. We're going to be on this line here. I know I don't have numbers, but can you just kind of walk me through taking your best guess at kind of what's happening on that line till kind of this line, this section here?
Constant user2 as an empty object literal.
Great. And where are we going to store that?
In the global memory.
Amazing. Let's go orange. Okay, user2. and it is an empty object. Okay, what happens next?
We're gonna add some properties into that object, and we're gonna add the key name with the value string 10.
Okay.
We're also gonna add the key score with a value of 6.
You don't have to mute yourself, by the way. You could keep yourself unmuted.
Okay.
So
and
score 6. Yep.
And lastly, we're gonna have the key increment as a function definition.
It's just a habit to mute
Sorry,
yourself
it's
so
just
quickly.
habit.
It's okay. Increment is a what? Say it one more time.
We're gonna function definition.
Function definition, exactly correct. Okay, amazing job. Sanjay Kim, thank you so much. Great technical communication, very well done. Now note that what we kind of the last two ways have the same effect, but at the end of the day, it's done a little bit differently, right? The first time we created this object, we created it, and then we added all the key values, what in the initial instance of that object literal. But this time we did it afterwards, which we can do, right? We could create an object and then later, after it's already been created and it's stored in memory, set key value pairs. I think just a little bit of a difference in that because we're doing it later, we create that object, but on, let's say, this line, user2.name, really, I think what JavaScript is going to be doing under the hood here is going to go, okay, is there a user2? Sure is. We know that. It's going to go name. It's going to go, is there a name property? Because if there is a name property, overwrite the value that's there and now make it 10. But if there's not a name property, create the property and then add 10. Okay, so something to note, there's no like const properties in objects. You can reassign properties at will. So it's the same idea, right? On score here, it's more saying like, is there a user to object? Yes. Is there a score property? If there is, update whatever values there to this new value of 6. Or if there's not, create the score property and assign it the number 6. Same idea. It's like a little bit of a subtle difference. Okay. Those are two ways. Let's go to our third way. Now, for many of you have maybe never seen what is on this line of code here. This object.create, okay? This is all I want you to know. For now, the only thing that matters to you about object.create is that it returns a new empty object. I'm going to say that again. Whenever you see object.create, don't worry about what's inside of those parentheses. Don't worry about the fact that it says null. It doesn't matter right now. For now, and actually for all time. It doesn't, we'll get into what we put inside of create later on matters, but object.create, regardless of what is inside of create, will always return a new empty object. Got it? Nico, I see your hand. I'll get to you when we finish this last piece, but keep your hand up, okay? Okay, so let's go. We're on that first line there, const user 3, and let's go with Yazed.
Hey.
Hello, welcome. Okay, so we're on that line. Good technical communication. Walk me through what's going on there.
All right, so we're declaring a constant user3 and we're assigning it the value of object.create with null passed in as a parameter.
As an argument, right?
As an argument.
Because remember, just as a heads up, parameter is the placeholder, argument is the value we pass in, and you are correct. Firstly, where are we storing this information?
Global memory.
Exactly correct. That is user3. And it is the result of invoking the create method on the object. They go object. Yes, that is true. But do you recall, what does object.create always return?
function?
Not quite. Not quite. It's all good. I just went over just a second ago, so it might have gone real quick. Object.create. So whenever you see big O object.create, whenever you see that, it always returns a new empty object. Always.
Okay.
So knowing that, Yazed, what does user3 equal?
An empty object. So
empty
it's just
object.
like undefined.
Yeah, well, it's just an empty object. It's not undefined. It's an empty object.
Okay.
You are correct in that we are invoking a function. We are invoking the create function, and then things will happen. And then, yeah, that might be undefined for a second, but we're going to not dive into that much detail. We're just going to say the function happened. We got the returned result. We're not going to add object.create onto the call stack. We're just going to know that object.create will return a new empty object.
Okay. Sounds good. Now the null, is that the name of the object?
The null we pass in there is not the name of, well, let me ask you, taking a look here, what is the name, the variable name in memory where we can reference this object? What did we call that?
User3.
Exactly. Now, null, it's a good question. Like, what's going on with that null? Like, what are we passing in there? We'll talk about that later. Don't worry about that for now, because regardless of what we pass into create, it will always return a new empty object. And that's what I want you to take away at this moment.
Okay. All right.
All right. So then we go to the next line. What's happening there?
All right. So we have user3.name equals Ava. So we're pretty much declaring the name key to the value of Ava. And so if name is in the user3 object, then it's good. If it's not, then we're assigning it a new key value pair inside the object.
Right, exactly. If it is already in there, we're reassigning it. If it's not, then we're creating the key and assigning it to the string Eva. Beautiful. What happens on the next line?
User3.score is assigned the value of 9. So we're doing the same thing. We're assigning a new key value pair. Score is assigned the value of 9.
Okay. And then lastly, what happens?
And then we're incrementing. So user3.increment is assigned the value of a function with no arguments passed in. And then we have user3.score incrementing by 1. So nice. Whenever so I'm assuming that's like another key value pair. So whenever we hit the increment, then that's when the score increments by 1.
Right. So whenever we call this increment function, and Yazed, do you remember what do we call functions in objects? We could call it a function, that's fine, but there's another term for it. Right. So whenever we invoke a method, then in this case, when we invoke the increment method, we will increment the score value by 1 in user3. But when we are just storing that initial key value pair, that key of increment and its value you said is a function, it is a function, but do you recall we kind of use another term? All the data inside of kind of these parentheses. Do you remember we called it a function something? Yes, exactly correct, Yazed. So increment is going to be a function definition. Exactly. And then that's it. Yazed, excellent job. Well done.
Thank you.
Great. Of course. Thank you. Great communication. So as we can see here, just 3 different ways that we can create objects, right? We could either, and again, the first 2 you probably were pretty familiar with, just create an object literal, add all the key value pairs when you're creating it. Great. Second one, probably also familiar, create an object, then add the key value pairs afterwards. Cool. Third one, probably less familiar, but equally as valid. Create a new object using the big O object.create method. Just returns a new empty object. And then, like the last time, add the key value pairs afterwards. Awesome. Let's get to questions. Nico.
Thanks. My question is, so in objects, my understanding is you can freely change properties within the objects. I was just wondering if there's anything significant about using the const keyword instead of the let keyword, or why you would choose one over the other when you're creating an object.
Of course, this is a really good question. So Nico asks, we know that we can change key value pairs inside of objects. We know we can change elements inside of arrays. So when we're declaring the initial, creating the initial object of that initial array, what's the value of putting const here? Like, what's the point of the const user2, const user3? So usually in your kind of early stages, you learn like let means you can change it and const means you can't, right? Const is constant, let means kind of lets you. That's not exactly correct, okay? What const means is it says you cannot change this whatever variable, whatever value or place in memory that this variable is pointing to, you cannot change. Let means you can. So this is what the const, when you are assigning it to a variable that's assigned to an object or an array, means. It says you can go in all you want and totally manipulate what's in that object or in that array, but you cannot change the value that user2 itself is pointing to. So if user2 is pointing to this object we created, and then we say, oh, I actually want user2 to equal the number 2, because user2 is in memory pointing at an object. And now you're telling it to point somewhere else in memory. You could even say, I want user2 to equal another object. It won't let you, because it is pointing to a specific object in memory. When you use const, it's pointing to a specific object in memory. And const says, you try to reassign what user2 is pointing to in memory, you can't do that. That's what const comes into play. It's the same thing with arrays. You can go inside of that array and do all you want, but the variable name is still pointing to that specific array or that specific object. You try to change that with a const declaration, you'll get an error. Does that make sense?
Yeah, thank you.
Okay, great. Let's go to Hank.
So what I wanted to ask is, do properties within an object work more like a const or like a let? Can you reassign, say, score to be an array? Could it be turned back in? Could it be turned into a string? Could it be turned into a function?
Yeah, all properties you can imagine. So properties are just variable names. Like there really is no difference if you think about it really under the hood. But you can think of it, Hank, like they're all declared with the let variable. You can reassign any property to any other, its value to any data type. So there is no const property.
Cool.
And there is no way to do that. So just to be aware of, like, objects work differently than like when you are declaring just like a variable in memory.
Cool. Thanks.
Mm-hmm. Let's go to Sherry. Or Sherry. Oh, actually, I think your question's in the chat. Okay. So Sherry's asking, will you clarify the difference between using the term instantiation versus initialize when describing these three objects? For example, can we say user one was instantiated and its properties were initialized? It's really like, there really isn't much of a difference. In fact, I would say there's probably no difference. Instantiated versus initialized, they both mean like when they were created. I think you could probably use them interchangeably. I mean, I could be mistaken on like the nitty-gritty detail of instantiated means, specifically with a non-method or a non-object versus initialized, but I use them interchangeably personally. Let's go to Ian.
This may be off topic, but like still on the topic of objects. Because you were talking about like the properties. To my understanding, like if we said let user3 and we created it the same way with our object.create, but we made it the exact same properties as our user2 object, and we like asked JavaScript if user 2 is strictly equal or loosely equal to user 3, it would say like, no, they're not equal at all because they're like separate objects. Would have to be like, they'd have to be user 3 would have to be equal to user 2, right? Okay.
So what Ian's asking is, you know how sometimes you may see like you might have declare a variable like, you know, let num equal 2, and then you might say let another num equal 2. And if we want to say, you know, is num equal to another num, this is true, right? Because 2 is equal to 2. However, if we wanted to ask, is user 2 equal to user 3? Even if this properties, the key value pairs are exactly the same, they are not equal. Why? Because they are different objects in memory. So yes, it looks the same to our eyes, but to JavaScript, they are completely different entities. They're both objects, but they're different places in memory. So even if the key value pairs are the same, JavaScript will go, those aren't the same. They're two separate things in memory. So they are not equal in JavaScript's eyes, even if they look exactly the same. Does that make sense?
Thank you.
Okay, great. Let's go to Chang.
Yeah, so I had a question about the way you created that empty object for user 3.
Mm-hmm.
So if you console log user 3 after you add all those keys and values, you can see the object.
Yeah, for sure.
Because when I tried doing it on the side over here, it's giving me an error saying that it can't read the property of undefined.
When did you write it exactly like this with big O object?
Yeah, big O object dot create null. And then I added one key, and then I tried console logging it, and it's giving me this error saying.
I'm not sure. This will work totally fine in JavaScript. So it should work. Maybe it's the environment. Maybe it's, I don't know. Maybe try in another Chrome or another browser or another developer environment. But this will work.
Okay.
Yep. KH.
I guess I have two questions now because I want to add on to a previous question.
Sure.
So in that example where you were examining strictly equals to, if you were looking at num, and let's say user2 dot score was equal to 2, and you were strictly comparing user.2 dot score to num, would it be true or would it be false?
So KH is asking if the score is the number 2 instead of like a user2 object, and we have a variable called num that's assigned the number 2, and we asked if they were strictly equal. Strictly equal means using 3 equal signs versus loosely equal, which is 2. I encourage you to look into the difference, but as a JavaScript developer, I will tell you, you never want to use loosely equals. But yeah, it would be true because 2 is strictly equal to 2. Even if it's a number inside of an object, inside of an object, inside of an object, the value is 2, and that is equal to 2.
Right, I figured, but I wanted to make
sure. Great question.
And then I guess my original question, and it might be nitty gritty, but or it's probably not that nitty gritty. But I guess curious, is there a difference between saying object and object literal? Is that the same thing, or is there like different subtypes of object, and or it can be object literals and objects of something else?
No, you could just, I mean, in essence, they're interchangeable. It's just object literal is just, it literally means these parentheses. You know, like when you're looking at these parentheses, it means this is an object literal.
Okay, yeah, I wasn't sure if it's just synonyms or like something now.
Great question.
Thank you.
Awesome. Well done. Good question. We'll go over to Jay for our last question, then we're going to keep moving on.
If you can make an empty object, like using the second method, why would we ever want to use The third one.
The third one?
Yeah, with the object.create null.
It's a good question, Jay. We'll get to why you would want to use object.create in just a moment. But if you're just trying to just create an object, you probably would not use it this way now.
Okay, thank you.
Yeah, good question. Yeah. You'll definitely find throughout our hard parts that sometimes we'll demonstrate like an example of coding to you that isn't how you would probably code it, but we're just kind of taking that next level because we're going to talk about object.create and its power a little bit later on. Excellent. Okay, with that, let's keep it moving here. So we just went over 3 different ways to create an object, but we have an issue here, right? Because this is Joanna's game, and Joanna has big dreams for this game. And we got 3 users here. What do we got? We got Will, Tim, and Eva. But Joanna's not hoping for just 3. She wants 3 million more, okay? And the last thing Joanna wants to do is every time a user signs up is to wake up, go to their computer, type in one of these 3 ways, create the name, create the score, add the increment function, right? That sounds like a nightmare. So we have available to us as JavaScript developers a way to create a set of instructions that when we say run, it will go and run that. Joanna, I know I'm giving you like all the basic ones. I want to ask you, what do we call that? Set of instructions, we bundle up, and then we say run.
A function declaration or an execution.
There you go. Exactly. We have functions. So let's use it, right? Let's use it. Let's create a function that's going to allow us to create user objects. So here we go. Board set up for us. We're good to go. We have the code on the bottom left here. We've now officially created a function so that now, you sign up, you put your name, you click submit, and that's going to go invoke this function and going to go do some work for us. Now let's go through this. Let's go with, who should we go with? Let's go with, and by the way, apologies on any name mispronunciations, but let's go with Besserat.
Besserat is how I would say it, but Besserat's pretty close, so that's pretty nice. It's pretty cool.
Say it one more time for me.
Besserat.
Besserat. Okay, Besserat. Okay. Yeah. All right. I appreciate that. Sure. Always let me know how you prefer it to be pronounced, okay?
No, I appreciate it.
So Besserat, I saw you raise your hand. This is your first time. Again, welcome.
Thank you.
We're going to start on line 1 here. Just again, trying to use that good technical communication, the best of your ability. Let's walk through what you think's going on here.
Okay. So first we're going to define user creator with, I'm so bad at this. The arguments, or is it parameters of name and score?
You are correct, but we're actually not even going to worry about the parameters quite yet. We're going to talk about parameters and the arguments when we actually run this function. Let's just talk about the name and where we're storing this information.
And we're going to store the function user creator in global memory as a function definition.
Well done. Excellent job. Okay, so let's switch up the color. Let's go this green. So let's go with this user creator. You know what? I know myself. I'm going to give myself some more room here on this memory because I know I'm going to want that. Okay, so let's go green and let's go user creator. And its value is the function definition. Now, Besserat, we are on line 1. What line does JavaScript go to next?
It should go to line 10.
Exactly. Well done. We go to line 10 because we haven't called this function. We're not entering yet. We go to line 10. What's happening on line 10?
Line 10, we're is it declaring user 1?
Mm-hmm. And where are we storing it?
In global memory, and we're gonna store it equal to user creator, like with the parameters will and the number 3.
Nice. So again, really great job. So this is a good, you know, again, we talk about the technical communication. Whenever you see a function invocation, kind of like on line 10, I'm going to give you guys the like go-to beautiful sentence to know what's going on here. So like Besrat said, we're declaring a constant variable user1 in global memory. You ready for this? We're going to assign it the evaluated result of invoking user creator with the arguments of the string will and the number 3. I'm going to say it again because I know it's a mouthful, but it is pretty, and I don't think you can deny that it is pretty.
Yeah,
we are declaring a variable user1 in global memory, and we are assigning it the evaluated result of invoking user creator with the argument string and the number 3. Okay.
Okay.
All right. Bismarck, do you want to try that? Say it back one more time. You think you got it? I know it's a lot.
No, I didn't get it. I'm going to try. Okay.
Okay.
We're going to assign the constant user1 we're going to assign it. With user creator. I don't got it. I'm sorry.
It's okay. It's okay. It's okay. We're going to say it like 100 more times.
Yeah. I'm going to write it down.
Evaluate. Yeah. By the end of this, you're going to be like screaming about how it's just like you're dreaming about this phrase, and it's like an earworm. You're like, oh my God, if I have to hear evaluated result. But here we go. It's going to be the evaluated results of invoking user creator with the argument string, with the arguments of the string of will and the number 3. Okay. So we did invoke a function. Now people, newbies included, because you know what's happening here. When we invoke a function, unmute, you know what we're doing. Let me see more unmutes happening there we go. We invoked a function. So we're creating a new
execution context.
Nice. A new local execution context. So let's do that. Let's open that up. Move that here. This is user creator. Paste the image. Okay. Bisrat, there's like 2 more things I'll need you to help me out with. We just created a local execution context, but we have some setup we need to do on the call stack. Do you remember what we need to do with the call stack?
We're gonna push the stack, push a stack. I guess we're pushing user creator onto the global call stack.
Yeah, exactly. Well, we're pushing the user creator stack frame onto the call stack. Exactly correct. So
stack frame.
Let's do that. User creator. And because user creator is at the top of the call stack, what needs to enter this local execution context?
Thread of execution.
Nice. Excellent. Bisrat, excellent setup. Very well done. Truly, you should be proud. That was very good. All right. Well done. Let's now move into kind of the body of this. Let's go with Rye. Is it Rye? Okay, beautiful. Rye, let's go over to you. Now that we've entered this local execution context, what's the first thing we need to do?
All right, let's pair our arguments with and parameters.
Beautiful. So what are they?
We are passing in the string will, which is going to get paired with the parameter name, and the argument number 3 that's going to get paired with the parameter score.
Amazing. And where are we storing this?
These are going to be stored in local memory.
Exactly. So in our local memory, the first thing, now that we entered the local execution context, we need to pair our arguments and our parameters. As a reminder, the parameters are the placeholders, P, parameter, placeholder. When we declared the function, arguments are the data we're adding after. So I say after arguments, parameter, placeholder, okay? So name is Will. Score is 3. Okay, what happens next?
Sweet. Let's move on to line 2 and declare a new const labeled new user, and we're going to initialize it as an empty object.
And again, where are we storing this?
This is going to be in local memory as well.
Exactly. So we have new user, and it's going to be an empty object. All right, keep it going.
Sweet. Okay, line 3, we're looking to initialize a new property on the new user object. New user.name is going to equal name, which is our property, which is the string will.
Great.
And then again, we're going to do a score property on new user, which is equal to the parameter score, which was assigned the value of 3 when we invoked this function.
Nice. Okay.
And then lastly, not lastly, but the last parameter that we're going to add is going to be increment, which is going to be the function definition.
Right, exactly.
And 6, basically.
Beautiful. And just ahead, you said parameter. I think you meant to say we're not adding a parameter.
Oh, property. Sorry.
Right. That's right. We're adding the property increment.
Property or a key. I like to say keys, really, because then there's not less P's running around.
I agree. I mean, yeah, key is, they're interchangeable, but I think key is, it's also 3 letters. You don't have to write it. It's not as long. Again, efficiency, people.
One syllable.
Any way you can. So that is a function definition. Again, apologies. I know it's pretty small there, but we have finished and added that last key. What line do we go to next?
Nice. So we made our empty object. We assigned a bunch of properties to it. And now we're going to kick that new user populated object, return it out of the function back to its source call in global memory as user1.
Exactly. Because on line 8, which is where we went to next, we saw this very important return keyword. For those that don't know, return is a very powerful keyword in JavaScript. What it says is a couple things. What it says is whatever value is on the same line as the return statement, that's the value I want to be returned out of this execution context to wherever it was called. So that's a lot, but that's the first thing it does. And the second thing it does, it says, oh, I hit this return statement. I'm done. The thread is done in this execution context. You could have a bunch of code between lines 8 and 9. It's not happening. It ain't getting seen. Because once the return statement hits, JavaScript's thread is out of that execution context. So we hit that return statement, like Rai said, we're going to return that back to where it was called, which was where, like what variable and where? Rai?
Oh, sorry. Yeah, we are going to be returning the object new user back to where it was because when we called this, we called it from global memory. So we're returning it back to the user1 const in global memory.
Exactly. So user1 is now this object. Rai, we hit this return statement and the end of our function block. So we have some cleanup we need to do. What do we need to do?
Yep. Let's take the toe out of the global execution context.
Nice. Or not out of the global execution context, but
I'm sorry, out of the local. Thank you. Yep, totally.
Yeah.
Into the global. And then once that's there, we are clear to garbage collect, which will, yep, remove that from memory. And then we also want to pop that user creator stack frame off of the call stack.
Amazing. Rai, excellent job. Very well done. Great technical communication. Okay. Well done. We have finished line 10, but we have not finished all of our code. So we're going to move over to line 11. Let's go over to William Leach's. So William, we're on line 11. Walk me through what's going on there.
Hi, we are declaring user2 constant, and we are assigning it the evaluated results of user creator being passed the arguments Tim and 5.
Beautiful. And where are we storing this?
We will be storing this in global memory.
Nice. That's right.
New
right.
object.
Okay, great. So as William said, we are assigning user to the evaluated result of invoking user creator with the arguments of the string Tim and number 5. People, you know the deal here. We have invoked a function, which means, I'm slowing down so people can catch up with the unmuting. We are creating a new
local
execution
context.
Nice. Okay, there we go. There we go. So we're creating a new local execution context. Again, I have shortcuts for that I'm really proud of. Okay, then we go and no, we don't move you. You have to stay, but you have to go. Okay. William, we have some setup. What do we need to do?
We are going to pass the arguments into local memory.
Not quite. We have some other setup we need to do.
We're going to go into the function body.
Not quite. Let me ask you,
Mm-hmm.
is JavaScript even in this local execution context yet? How does it even know it's supposed to be in this local execution context yet?
Sorry, I'm blanking.
No, you're good. It's all right. Take a second. Oh no. Oh, we're good.
Not too long.
Here we go. So take a second and look at the screen.
Mm-hmm.
And do you recall there is a structure that JavaScript utilizes to know where it's supposed to be?
We're going to pop it onto the call stack, the stack frame.
Yep, but you are so close. We're not popping.
Pushing, sorry.
We're pushing, exactly. No, you're good, you're good. You are good. By the way, it is 8:30 on the West Coast. I don't know where the rest of y'all are. I have a coffee, an 8:30 p.m. coffee. That's how I do this. So you are excused. So let's
11:30 in Texas.
I mean, I'm so sorry. I'm so sorry. So we're going to push user creator back on. Actually, I'm going to go back to the color we had. Just so it's very clear, we're doing user creator back on. Okay, which means, right, our thread enters this local execution context. Now, where you were, right, what do we do next?
Okay, we're going to pass in our arguments, the string Tim and the int 5.
Beautiful. And where and to what?
To the user creator function body, into the into the local memory, and then it goes into the local execution context.
Right. So we're going to pair, right? Just to be very clear, our parameters and our arguments in local memory. So our parameters were right name, which is Tim, and score, which is 5. Okay, what happens next?
And then we're going to, so are we in the function body now, the user creator? So we're going to declare a const new user in the local execution context. Which
and
is
store it in where in the local execution context?
In the local memory.
Nice. Yep.
Empty object.
Okay, what happens next?
And then we're going to assign the key name to the value of the argument, which will be Tim.
Okay.
And the key score to the value of the passed in score, which is 5.
Okay.
And then we will also assign the key increment, the function body of
I mean, it is in theory the function body, but what do we call that here?
Well, it's a method, but the other term was is it function expression?
Close function
the definition.
Function definition.
Definition.
That's right.
Okay.
Okay. What happens next?
And then we are going to return out this new user, which will be our evaluated result.
That is right. We are going to return. Here we go. This object. And where are we moving it to?
It'll move into global memory. It's right where you have it.
At user 2. Okay. We hit that return statement, so we have some cleanup. William, what are we going to do?
So we're going to pop the user creator off the call stack, make it eligible for garbage collection.
And our thread returns where?
Returns to the global execution call. Yeah,
that's right.
Bottom pancake. Yes.
The bottom pancake, exactly. William, excellent job. Well done. Thank you so much for getting us through this next invocation of user creator. Okay, so now we have 2 user objects in memory. There is a line 12. I'm just going to kind of walk through it, right? It says user1.increment. So we'd go to user 1, we'd increment user 1, right? From 3, it would become 4. Okay, kind of a similar idea. Well, we have a benefit here than what we were doing before, right? Joanna is no longer waking up every single moment that someone signs on to their application and their quiz game. And this is better, right? We are invoking a function, but this isn't ideal. And I'll tell you why. If we look at our user objects, sure, there's a different name, and that's important. We have Will and Tim. We have different scores. That's great. But the same exact function of increment is in each user object. And sure, you might say to yourself, okay, Reid, well, it's 2 increment functions. Who cares? It's not like that insane of a memory usage. But again, Joanna's got huge plans for this. We're not talking about two users. We're talking about 30 million users. So think about it. If we added users this way for every user, what we would essentially be doing is writing the exact same increment function over and over 30 million times. We just have 30 million copies of the exact same function. There's nothing unique about this increment function from one object to the next, right? Name, I get. Score, I get. But rewriting increment over and over for every single new user object, that is not efficient. That is not a good use of your memory. So what if, bear with me, people, what if there was a way in our code where instead of writing this increment function over and over and over again for every single function, what if instead what we could do is what if we could have, like, I don't know, another place in memory. Let's just call it, you know, a user function store. So what if we could have another place in memory called a user function store that stored this, you know, the shared functions that all our objects are going to need to utilize, but it's just the same concept, you know, same function body over and over and over again. What if we could create a user function store that had, you know, like this increment function inside of it? And so instead of, you know, rewriting increment over and over and over again, what if instead what we could do is when we create these new user objects, we could create some type of a bond. To this user function store. And so when we invoked something like user1.increment, what if JavaScript could go, hey, let me go look at user1. Is there an increment function in there? If there is, run it. But if there is not, don't panic. Go look at this bond, see where it's pointing to, and see if there's an increment function there. Same thing if we wrote user2.increment. Is there a user2? Yes. If there is an increment function inside of user2, run it. But if there's not, don't panic. Look at this bond, see where it's pointing to. Is there an increment function there? If so, run it. Okay. If there was a way to do that, then all we would need to do is write one increment function in memory and tell every user object, hey, you know, create a bond with this one user increment, this one increment function, instead of me rewriting it over and over and over and over again. So let's see if that's hypothetically possible, okay? Here we go. Okay, people, we're gonna keep moving fast through this. We are running a little bit behind, that's okay. I'm here with you, but we're gonna kind of speed it up a little bit moving forward here. So let's go with Das Kang. Das, we're gonna go on line 1, and apologies if this is too small, let me know. I can try to make it a little bit bigger, but so you got it? Okay, so starting on line 1, walk me through what's going on there.
So we're going to declare function labeled user creator and store its function definition in global memory.
Beautiful. Okay, what happens next?
And we're going to skip to line 7, declare constant label user function store and assign that to the object, which has key increment, and assigning that to value of function definition. Same thing with the login. So key is login, and the value is going to be the function definition.
Beautiful. What happens next?
And we're going to jump to line 11. Declare constant label user1, and that is assigned to evaluated results of invoking function user creator with argument will and number 3.
Beautiful. People, we invoked a function. So we are going to be creating a new
execution
context. Nice.
Context.
We got a little straggler there, but I appreciate it. Local execution context. That's right. So let me get that going. And I'm going to stick with you, Das, just with, again, you're doing so well. And great technical communication. So we have our local execution context. Let's kind of put this user creator. We have some setup we need to do with the call stack. What are we going to do there?
So we're going to push that user creator stack frame into our call stack. And our toe will move into our local execution context.
Okay, what happens next?
And then now we need to pair our parameters and arguments. The parameter name is assigned to will. Parameter score is assigned to number 3. And then we're going to declare const new user, which is object create with user function stores. So we're going to the object.
Nice. So exactly correct. Again, we're going to dive. We're so close to explaining why inside of create, what we do there. But again, just for this moment, we know that object.create returns, and you said it, but one more time, object.create, regardless of what we pass as an argument into create, will always return what? An empty object, right? So, okay, what happens from there?
And in that object, we're going to add key name, and that is assigned to name. Key score is what? Name is will.
Okay.
And key score, that is assigned to score, which is 3.
Okay.
We're going to return that new user object to our global memory where user 1 is.
Okay. Let's make sure I can do this. Okay, we have finished up the code. What we need to do there for our cleanup, Das?
Yes, we need to mark our local execution context for garbage collection, and we need to of our stack frame off from the call stack.
Right, and our thread returns where?
Out to global execution context.
Nice. Das, excellent job. Very well done. Next, let's go over to Hank. Hank, we're on line 12. It's going to look oddly familiar, but let's go through it again.
So what we're going to do is we're going to create a new constant labeled user2 and assign it the evaluated result of invoking user creator with the arguments Tim and 5.
Beautiful. Okay, so people, we're invoking a function. There aren't that many more of this. So let's wrap up strong. I think there's only a couple more. So we're invoking a function, which means we're creating a new
Local execution
context. Amazing. Still going strong. I love it. Okay, so we have a new local execution context. This is for this invocation of user creator. Okay, we know our thread enters, but we have some other setup we need to do, Hank. So what else do we need to do?
Pair our arguments to our parameters.
Not quite. There's one other thing before we do that.
We need to push user creator to the call stack.
Exactly. So we're pushing user creator. Okay. Now what do we do?
Pair our arguments to our parameters.
Okay.
So we have the name Tim and score of 5.
Okay.
Now we're going to move to the next line, which creates a new constant, new user, using the object.create definition.
Yeah, and invocation, and what does that always return?
Invocation returns a empty object.
Okay, what do we do then?
Now we're going to add the key value pairs to that empty object. So, so we're going to assign our name argument to name. So name is Tim, and then we'll do the same with score. So score is 5. Now we're on line 5. We return. So we exit the local execution context. We return new user to the global memory. And
where?
Sorry?
Where in global memory?
User2 in global memory.
Beautiful.
And
okay.
That means that we can now push, or we can now pop user creator off the call stack, and that user creator is eligible for garbage collection.
Great. And our thread returns where?
Back to the global execution context.
Hank, very well done. Excellent technical communication. Okay, next up, our last line here. Let's go over to Brian Taylor. So Brian, walk me through, and then I'll get to questions, but walk me through just say line 13, what that code out loud, just read it.
I cannot see line 13. Would you be able to scroll down?
Yeah.
All right, so we are using the increment method on our user1 object.
Right, okay, so that's what we're invoking, right? So let's go just with our eyes, and if you know this, don't spoil it, right? If we go look, we're gonna go look, is there a user1 object in memory, Brian?
Yes.
There is, right? We see it right here. Looking at this screen, is there an increment method in that object?
No.
No. Are we gonna panic?
No.
Is JavaScript gonna panic?
No.
No, right? What did I say earlier? Where would we hope JavaScript would look at next if it can't find what it's looking for in the object it's currently in?
It'll go to global memory.
It could go to global memory. That is kind of a path it can go. But do you remember, it's not technically the formal name, but if we look here, what was that kind of?
Oh, the bond.
The bond, right?
It goes
Okay.
and looks at the bond.
The bond, okay.
Or the link.
The link, exactly. So Brian, I'm going to get back to you in a sec. I'm going to explain this, so I'll get back to you in just a moment. So let's talk about this bond. People, do you remember this whole time I've been saying we're going to talk later about what we put into object.create. For now, don't worry, it always returns an new empty object. Well, now it's time to talk about it. Whatever you pass in, there are two options that you can pass into the create method on that big O object. You can pass in null, which means one thing, but you can also pass in another object. You can also pass in another object as the argument into create. And what that does is it will automatically set for us the bond of these objects to whatever object I passed into create. So remember, I get this object back on line 2 because object.create always returns a new object. But this is a special object because this object had its bond set to user function store. We had this bond set to user function store, right? We see that on line 2. We passed user function store, that object, into create. So the object that was returned from object.create had its bond set to user function store. Now, I have been saying bond to you, but that is actually not the technical term of bond. There is a technical term, but it is a scary sounding and looking technical term, but never lose sight of the fact that it's just a bond. That's really all. It's a link. That's all it is. Brian said link. I think that's a great explanation. So the technical term is not bond. And this is literally a property on these objects. It's not called bond. The term is written as underscore underscore proto. That's way too thick. Let's try this again. Proto underscore 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 proto underscore underscore. This is known as the dunder proto, the double under proto, dunder proto, underscore underscore proto underscore underscore. So weird looking, so weird sounding, but that's what this is. We have set these objects, their dunder proto to, which is a property on this object. Its value on both of these objects is the user function store object. So remember when I said we invoke increment, the JavaScript engine looks at user 1, doesn't see increment. Does it panic? No, it looks at its bond. It looks, it's not bond anymore, right? It looks at its dunder proto, which is pointing to user function store and looks there. Okay, so knowing that, Brian, we're going to do this, continue from where we were. We are looking on line 13. We have user 1. We looked at user 1. We didn't see increment, but we didn't panic because we know now if the JavaScript engine can't find user 1 or increment in user 1, it's going to look at its dunder proto. That's pointing to user function store. Brian, is there an increment function there?
Yes, there is.
There sure is. So we are invoking increment, which means we are invoking a function, which means we are creating a new
local execution context.
That's right. That's right. Now I'm going to clear up some space for myself. So I'm actually going to delete some of these. Okay. Okay, so we are creating a new local execution context. It is for this increment. Actually, even specifically, user1.increment. Brian, we have some setup we need to do. What do we need to do with the call stack?
We are going to push the increment stack frame onto the call stack.
Exactly. Which means our thread enters this local execution context. What do we do? Well, I'll explain what to do, but go read the code. What does increment function do in this code block? What does it, word for word, what is it saying increment does?
So it is incrementing this object score. So whatever object is working on incrementing that score.
Right. So to be more specific, I'm just going to go exactly verbatim what it says here. It says, this is going to look really weird. This dot score plus plus. So increment score on this. Brian, I'm about to go on another tangent, so I'll be back to you in just a moment. Okay, people, I know I just threw a lot at you with the Dunder Proto, but I'm not letting up because I know you can do it. Here's the next piece I want to talk about, which is the concept of this. Notice that when I say this with air quotes, like I'm doing here, I'm talking about the this keyword. The reason being that it's hard to see, I'm doing it right now. It's hard to not say this, referencing like the not this keyword, this. So when I say this, I mean, I'm talking about the keyword this, okay? This, that keyword is, I think it's fair to say, probably one of the biggest complaints, headaches, frustrations JavaScript developers face. Firstly, because they called it this. In other languages, like I think Python, it's called self. I think that's a better term, but it's called this. And this has many rules, many rules. Essentially, this is just referring to the context in which this is referring to, okay? Now, there are, I think, 7, 8, 9 different ways in which we can assign this. I encourage you, tonight we're going to talk about 2 of them. We're going to talk about 2 of them tonight. There are more than 2. We're going to talk about 2. If you're very interested, there is an article. I'm going to look it up. I think it's called The Gentle Explanation of This in JavaScript. It's called Gentle Explanation of This in JavaScript, dimitripavlutin.com. That was very helpful for me. It's a resource I definitely recommend. We're going to talk about one of the rules, okay? When you are invoking a method just means a function in an object. Whenever you invoke a method, if you are utilizing the this keyword within that invocation of that method, this will be assigned, always be assigned to the value to the left of the dot of the method invocation. That's just the rule. It's just a rule for you to absorb. Whenever you are using the this keyword in a method invocation, this will be assigned to the value of whatever's to the left of the dot. So knowing that, that's just how this works. Brian, what will this be equal to inside of the user1.increment execution context?
So it'll be equal to the the object of user1. So this will be to user1, basically.
Exactly. So this will be equal to user1. So Brian, the first thing I want you to do is look inside of local memory. I know it says the term user1, but is the object user1 inside of that local memory, the object itself of user1 inside that local memory?
No, it is not.
Right, it's not, right? It's going to look here, it sees user, this is now equal to user1, but it's not there. So where's JavaScript going to look next to see where user1 is?
In global memory.
And is there a user1 object there?
Yes, there is.
There sure is. So what is it going to do?
So this is going to increment score.
That's right. So 3 becomes, not 3, 3 becomes 4. We are now done with this local execution context, Brian. So we have some cleanup we need to do. What do we need to do?
So this current execution context is not eligible for garbage collection. We're going to pop the increment stack frame off of the call stack, and the thread of execution will go back into the global execution context.
Exactly. Brian, well done. Excellent job. Way to connect us on a really advanced piece there. Okay, folks, we're not done yet with tonight's workshop. I know, but I just want to do a little quick recap because this is a huge slide. This is a big leap we just made. When you create an object using the object.create, big O object.create function, that method, whatever object you pass in as an argument, because you can only either pass a null or an object. If you pass in an object, then that new object that gets created, its dunder proto points to the argument object. So the object gets created, its dunder proto is pointing to, in this example, user function store. So when we invoke a function, first, JavaScript is going to look inside of, or we invoke a method. It's going to look inside of that object and see, is this method there? Because if it is, it's going to invoke it. But if it's not, it does not panic. It's going to then go look in its dunder proto, see what that's pointing to, and check there. Is there an increment function there? It was, so we invoked it. But we saw that it said inside of increment, this dot score plus plus, which is our first rule of this, which is when you invoke a method and that method, that function definition of that method utilizes the this keyword, this will be assigned to the object to the left of the dot. Just the rule of this and method invocation. Okay, let's go through a couple questions and then we're going to move on to our last, where we have one quick diagram and then a little bit of a longer diagram. Okay, let's go with Bogdana.
Hi. So my question had to do kind of with like me being lost on like line 3, where it says new user dot name equals name. Is the dot name referring to the local memory of the name, the stored name, or the, like in parentheses, user creator name?
Right. Good question. So if we look at line 3, and let's say we had, an object, we have new user is an object. This piece here is setting the key name to this piece here, which is the data, the value stored at the variable of name, which was the argument passed into name.
I see.
So that would be was Will or then Tim. But to the left hand of that equals is we're creating a property called name. To the right is we're assigning the value stored at the variable name.
I see. So if it said like dot flower, you would put in that object flower colon and then the equals to name, like whatever the argument that was passed in.
Exactly.
Okay, gotcha. Okay, makes sense. Thank you.
Of course. Jay?
So the dunder proto, it points to an object with different methods in there. Could it also have just different keys and values in there as well? So like if you have, okay, so like if you like created a key in the user function store, like I don't know, like the high score, and then like you could access it that way, like the same way as you do in like line 13.
You could, the thing I would be careful if you called it high score is the only thing you want in this like user function store is data that is not specific to an individual user, right? Because if we had something called user like high score, well, anytime I used high score for any user, it would change that singular high score. It wouldn't keep track of individuals. So individual information you're going to want to keep in that user object, but like functions or even variables like data that's like if you wanted to find like the global high score, like what's the highest score anyone has, then maybe you would put that inside of a shared object or a shared like a user function data.
Okay. All right. Thank you.
KH.
In the object.create function, can you pass in multiple objects for multiple Dunder protos, or is that the purpose of creating classes?
So you can't put, you can pass in, so object.create has, you can't pass in multiple Dunder, like you can't pass in multiple objects to be, Dunder proto points to one object. That's how it works.
Right.
You can't have
like
Dunder proto point.
You pass an array of objects, so you can have multiple connections.
No, it can only have, it's a one-to-one connection. One-to-one connection. You can pass in a second argument, but that argument has nothing to do with the Dunder proto. And you can look that up on MDN if you want to look up object.create. You can see what the second argument does, but it has nothing to do with the proto. Okay, good question. Last question for now, and then we'll keep it moving. Let's go to Brisa.
Hi, can you hear me?
Mm-hmm.
Okay, so just a quick question on this keyword. So what happens if you use it within a constructor function, and then you call that constructor function later?
Yeah. What a great question, Brisa. In fact, it's such a great question that we're going to go right into explaining that concept. So Brisa, excellent setup for me. You're doing my job for me. Okay, so Brisa asked a good question, which is a terminology I'm going to talk about in a second. Let's just first wrap up our assessment of this way. So we know this is, again, Joanna's game. We didn't like the first solution that we had, which was just creating objects willy-nilly. For each object or each new user. We then tried another one. Let's create a function, like a user creator function. But the issue with that is that we were writing like copies of our increment function over and over and over again for each user, a waste of memory. This time we have a much better use of memory. But I will say that this is not how we really do what we're trying to accomplish here in modern JavaScript. Okay. I think there's kind of two reasons to that. One is we have this floating user function store just like sitting out in global memory, and it has all of our really important functions, and it's so vulnerable. If you leave information in a global space, it's a vulnerable place for information to just live. So if someone accidentally like deleted our user function store, we'd be in a really tough spot, right? All of this user functionality is just gone. So I think one issue is like, this important object is just kind of sitting in global space. But two, we have actually another way that we can try to do this. Now, what if there was a way? Here we go. Remember I talked about how lazy developers are, right? This is it's beautiful, no problems. Maybe a little long-winded, but oh man, every time we have to write these 6 words, every time I have to create a new user, I have to invoke object.create, I have to return that user, blah, ugh, what a drag. What if there was a way where we don't need to create a new object, we don't need to return a new user? What if we just gonna get around that? But you may be asking yourself, well, Reid, here's the thing. If I don't create the new user object, then these lines right here are going to error, right? Like if we're not creating a new user object and like creating a variable, a place in memory to reference this new user object, then when we try to add a name key, a score key, values, we're going to get an error. And if we're not returning it, then even if for whatever magical reason this worked, well, the object would just be sitting inside of user creator, never returned to where we invoked it. Okay, well, let's think if there's a tool in JavaScript that allows us a really cool way to avoid this problem. Now, before I even do that, I want to dive into functions, and then I'm going to talk about the solution, and then we're kind of on our last solution here, our last diagram. In JavaScript, we know we have objects, we have arrays, we have different data types, but here's the beautiful thing, a really interesting thing about functions. In JavaScript, pretty much everything is a function. Pretty much everything is an object in JavaScript, which is what makes it such a great language for object-oriented programming. Even functions are also objects. They're a special kind of object, but under the hood, they are also just objects. So if we take a look, I'm going to diagram through this myself. If we take a look at the below code snippet, we see in global memory, we're going to have a multiply by 2, which is a function definition. And here's the thing about functions. Functions, like I said, are also just objects. They really are. They have a special property on there called, I believe it's bracket, bracket, call, bracket, bracket, which kind of is a special property that lets JavaScript know that this is a function. But every function is also just an object. So if we go to that next line of code where it says multiply by 2.stored, well, what we're doing is we're just adding a property of stored and setting it equal to the value of 5. Well, we could also, on the line after that, invoke multiply by 2, push multiply by 2 on the call stack, run it the way we've been running functions. But if on the next line over here, we console log that, well, 5 would show up because it's an object with a stored property and a value of 5. And here's another part of function objects that are important. All function objects come built with them automatically a property called prototype. And prototype's value, so again, function's an object. Every function object has a key called prototype. Its value is also an object. Now, why does this matter? We're going to get to that in just a second. But I want you to take this note right here. Functions are objects. And every function object built into it has a key called prototype, whose value is also an object. Okay? Now, why does this matter? Well, this is really where the power of JavaScript comes into play here. Here we go. We're on our last diagramming. We're going to really bring everything together here before our last little wrap up. I know it's already a little bit past 9 Pacific, but we're on our last one. So strong here. Let's end strong. We're going to use good technical communication. Let's go over to David Lee. David Lee, we're going on line 1.
Oh, God.
Walk me through what's going on here.
Sure. We're going to declare a function called user creator with the parameter name and score.
We're not going to really talk about parameters, right? We don't really go to parameters.
It's function definition. Yep.
So its value is a function definition. Okay, where do we go next?
Line 5.
Actually, even before that, sorry, David.
Yeah.
Remember, I said user creators are functions, but functions are also what, David?
Objects.
Okay. And we know now that function objects have a property on them every time. What's the name of that property?
Prototype.
Prototype. And its value is always what, David?
It's always object.
An object, exactly. Okay, so knowing that, we are on line 5. Walk me through what's happening on line 5.
I don't know how to say this in technical term, but I think it's
go piece by piece.
It's user creator prototype.
So what's the first? Don't worry. So we'll go dot by dot. What's the first part of that dot? Right before, to the left of the dot. The first thing you see.
Function name user creator.
Okay, so we see user creator. That's in memory. We know that's there.
Yep.
What does the dot always tell you?
Key.
Yeah.
Yep.
We're gonna look for a key. What's the name of the key?
Prototype.
Okay. Is there a prototype key on the user creator object function
Yes.
object? Sure is. What's the next thing we're gonna do?
We're gonna look for increment.
Okay. Is there an increment in there?
It's not, so we're gonna declare it, or we're gonna put it in.
And what is increment's value?
Function definition.
Exactly. I guess I'll switch up the color. Okay. What line do we go to next?
Line 8.
Okay. What happens there?
It's another. It's function user creator, and we're gonna look for a key prototype, and it's there. And from there, we're gonna look for key login, and it's not there. So we're gonna. Do you say assign it, or do you say?
I would say like we could say assign. We could say declare.
Declare login, and assigning to a function definition.
Nice. Okay, where do we go next?
And then line 11.
Okay.
I wrote this down. So we're gonna declare constant user1, assigning it to a evaluate result of invoking the function. User creator, passing in the arguments string Eva and number 9 with this part I forget. With the new function. How do you say that?
Close. New. You can either say new keyword or new operator.
New operator.
Okay. Beautiful. David, I'm going to explain. So you see there's this like new thing going on. We'll get to that in literally just a second, but David is spot on. And David, you did an excellent job, right? We just put a couple methods inside of the prototype object on the function user creator, right? And its object. Well, line 11, we're invoking a function. People, this is the second to last time we're doing this. So let's end again our second to last time. We are invoking a function user creator. So we're creating a new what?
Local execution context.
Okay, beautiful. Local execution context. This is for, new user creator. David, we have some setup. This is no different than anywhere else. We have some setup we need to do with the call stack. What do we need to do?
We're going to push the user creator stack form.
Stack frame. Nice job. Good job. User creator. Okay, which means our thread enters the user creator local execution context. And this is where things get interesting. Well, first things first. Actually, David, I'm going to pass it off. Excellent job. Just to give everyone else a turn. Well done, David. Seriously, like that was excellent job. Way to reason through that. Let's go to Patrick Vong. Patrick.
Yep.
Now that we've now entered this local execution context, what's the first thing we need to do?
We have to pair off our arguments and parameters.
Excellent. So what are they?
The Ava is equal to name, or name is equal to Ava, sorry. And score is equal to 9.
Okay. Now, this is where things get interesting. People, do you remember how I said, Patrick, I'll get right back to you. I'm going to go on a little tangent here. Remember I said we're going to go over 2 rules for this tonight. The first one was when you're invoking a method, this, and you use the this keyword in that method, the function body of that method, this will be assigned to whatever object that is to the left of the dot, right? Here's the second rule of this. The new keyword. So people, remember I said, oh, those 6 words were so annoying. Creating a constant user object, returning the user object. What if there's a way we could get rid of that? Well, that is where the new, literally, what do we got here? The new keyword comes into play. And this is an operator, a keyword within JavaScript. And when you ever put the new keyword before a function invocation, JavaScript will automatically do 4 things for you just by using the new keyword. It will do 4 things for you automatically, okay? First thing it will do is automatically create a new object. Automatically create a new object. The second thing it will do is it will assign the keyword this to the new object automatically. So inside of a function that uses the this keyword, if you use the new operator when you invoke that function, you will automatically get a new object inside of that function, and this will be assigned to the new function inside of that local execution context. Automatically, that's 2 of them. Third thing, JavaScript, if you use the new keyword, will automatically assign the dunder proto of that new object. Pay attention here because it's going to be a mouthful. Will automatically assign the dunder proto of that new object to the prototype object in which that object was created. Meaning, if we are invoking user creator using the new keyword, we're getting a new object. This will be equal to that new object, and the dunder proto will point to the prototype object on user creator automatically. It will automatically take proto and assign it to prototype. It will take the dunder proto and assign it to the prototype object on the function that is creating your object right now. The fourth thing it does is automatically return that new object at the end of your function block. So I'm going to say it one more time because I know that's a lot to take in. We're going to, by just by writing new before invoking user creator, you put new user creator, you get a new object. This gets assigned to the new object. The new object's dunder proto points to the prototype on the function that's creating that new object, and it will return the new object at the end of your function block. So knowing that, Patrick, walk me through, we're on line 2. We know now that this is equal to the new object we just because we invoked it with new, just because we used new, we got a new object. This equals that new object. What happens next, Patrick?
So we'll create a new property name and assign it equal to Ava.
Nice.
And then we'll create a new property score and set that equal to 9.
Okay.
And then
what happens next, right? We don't even have to do anything, but we just know because this is what the new keyword does. What happens next?
Right. So we'll return the whole object to user 1 in global memory.
That's right. Let me get rid of this here for a sec. Let me just fix it here. And we know, Patrick, that it's dunder proto points to which object? Where, Patrick?
It points to the prototype object in user creator.
Exactly. Okay. We've now finished this local execution context, Patrick. We have some cleanup we need to do. What do we need to do?
Right. So we have to pop the user creator call frame.
Stack frame, yep.
Stack frame out of the call stack. And we have to, the thread of execution moves to the global execution context and the local and then the local execution context is eligible for garbage collection.
Nice. Patrick, well done. Excellent job. Very good, very good. People, we're on our last line, last bit of logic. We're gonna put all of our learning together, all of our this rules together. Let's go over to John. John, we are on line 12. What's happening on line 12? Oh, you're muted, just a heads up.
Oh, sorry about that. Thank you. So in line 12, in our global memory, we are executing the increment function.
That's right.
That is
so people,
within user
just
one.
real quick, exactly, right? So we're invoking the increment method on the user one object. This is our last one for the night. So let's make it count. Let's end strong. We are invoking a function. So we're creating a new
local execution
context. Exactly. Okay. So let's do it. Let's add a local execution context. It's for. Okay, so we have some setup, John, we need to do. What do we need to do?
Right. So we are adding, or we are pushing the increment function to the call stack.
That's right. So let's push it. We got increment. Okay. So
and also,
John,
sorry, before I forget, I'm gonna also the thread of execution is coming into the local execution context.
Exactly. Now, John, remember, I know we just did this setup, but when JavaScript was looking at line 12, it said, okay, user one dot increment. Okay, cool. It said, let me look in memory, global memory. Is there a user one object? And John, is there a user one object?
Yes.
Sure is, right? The next thing it said is, okay, let me check. Is there an increment function in this user one? And is there an increment function in the user one object?
No, there is not.
No, right? But it didn't panic, right? It didn't freak out.
Right.
What did it look
next? Because of the bond, the Thunder Proto bond, the Thunder
and
Proto.
It's pointing to
the prototype object that is within the user creator function.
Exactly. And is there an increment function there?
Yes. Within the prototype object, yes.
Exactly. So we opened up the local execution context. We pushed a stack frame onto the call stack. We have our thread inside of there. What happens next?
So within the local memory, it's going to it's going to, if I'm not mistaken, it's essentially going to go to figure out what increment is, what the value of increment is, which will essentially we'll find in line 6, where it would increment the score.
Okay.
Or this,
right, says this.
See that this will, yeah, this dot score plus plus, which will increment the score.
Okay, great. Now, do you remember, John, when it comes to using this keyword in a method invocation, we have a rule. What was that rule? How do we know what this is going to be equal to here?
So one of the rules is that this is equal to the, was it the object that is left of the period? So this is in regards to user one object.
referencing user1 object.
Right? When we have this keyword in a method invocation, this will equal the object to the left of the dot. So we know that, see that's user1. So first thing it's going to do, John, is look in local memory. Is in the local memory for increment, is there the user1 object in local memory?
No.
No. Where does it look next?
Then it goes into global memory.
And is there a user1 object there?
Yes.
Okay, what does it do?
So it pulls that information or that object into local memory, and then it will look for the score value or the score key, and then it'll increment the value, whatever that score is, by 1.
Right. So it's 9. It's now 10. We're now done running our code. So we have some cleanup. What do we need to do?
Right. So now the increment will pop out of the stack frame.
The increment stack frame will pop off the call stack.
Yeah. Okay. So thank you. Increment stack frame will pop out of the call stack. And then the thread of execution will come back into global execution. And then the local execution context is now ready for garbage disposal.
Garbage collection.
Garbage collection.
Oh, excellent. And then we're done. John, way to go. Way to go. People. And then Daniel, I see you have your hand. I'll get to you in just a moment. But wow, this was a lot. This is a lot. But this is the essence of object-oriented programming in JavaScript and what we call the prototype chain. Now, the object.create, that kind of methodology we're using before, you're never going to really see that. You're never really going to see that in the workplace. It works, but you're never going to see it. But this you may see. This type of coding is very possible when you're talking about writing functionality and designing the creation of objects and its connection to functionality in an application, in a game, whatever it might be. So in this example, the reason why this is going to be more popular than the last time is, one, we get to use the new keyword, which means we don't have to create a new object inside of that function user creator anymore. The new keyword does it automatically. We don't have to use object.create instead of dunder proto. The new keyword does it automatically, sets the dunder proto to the prototype object on the function that's creating it. We don't have to assign this value. This is automatically assigned to the new object. We don't have to return that object. It happens automatically. The new keyword does that for us. In addition, by using this keyword inside of that method increment or login or whatever, we can generalize this to any object we create, user 1, user 2, user 3. As long as we do it this way, we can now apply that logic to all of our user objects. This way, we are being memory efficient and memory performant. We're not rewriting increment over and over again. We also don't have like a global user function store just sitting in memory. This is an object inside of a functions object. It's at least a nested function, one layer deeper. It's a little bit more secure. And again, it's way more readable. And this is a great way for later on if we decide, oh, we want to add a log out. We want to add a decrement. We want to add an avatar. Well, we just write user creator dot prototype dot decrement. And now every single object we've ever created with this user creator has access to that function because it's dunder proto points to the prototype, and we can just add whatever functions we want to that prototype. Okay. Now I have one last slide and then I'll get to questions because this last slide, there's no diagramming. This way that we just went over, faster to write, way more typical in professional practice. 95% of developers have no idea. This is called prototypal inheritance. We're using the prototype chain. It's different than pseudo-classical inheritance. Java use it a little bit differently. JavaScript, we use the prototype chain. Now, here's the deal. When we had developers, when JavaScript was, invented, and when this methodology, this implementation was created, and Java developers and developers from other languages came to JavaScript and said, what the hell is this? This is so weird, because in Java, this is not how we do this in Java, but not like this. There's no prototype. There's no using the prototypal chain. Java uses classes and class structure. And so the JavaScript developers, and by the way, I have the similarity between Java and JavaScript, they're both programming languages. They both are good for object-oriented programming, but there's this line I heard that I think it's pretty accurate, that the similarity between Java and JavaScript, oh, my iPad, one sec. The similarity between Java and JavaScript is like the similarity between ham and hamster. There's really not much besides the name. And actually, true story, the reason it's called JavaScript was to kind of convince people it had anything to do with Java, and it had nothing to do with Java. Let me try this again. Let me get back, start the broadcast. Okay, so because of that, I think in 2015, I can't remember the exact year, but JavaScript came out and said, fine, developers in other languages that have issues with this, we're gonna make this more smooth for you. You like classes, we're gonna give you classes. And that's where the fourth solution comes into play, using classes in JavaScript. And this is what's known as syntactic sugar. Now, what is syntactic sugar? Syntactic sugar just means that syntactically, in your writing, it may be a little bit cleaner, maybe fewer lines you have to write, but there is no performance benefit. There's no performance benefit. It may look cleaner, but under the hood, it's not any better than the way you were doing it before. So in JavaScript, we utilize now classes. And honestly, I would say this is the more common way you're going to see it. But under hood, using classes, constructors, you're going to see here, this is the exact same thing. If you look from left to right, you may see something like a class, user creator. Inside of there, you'll see a constructor function. But that is no different. Under the hood, this is exactly what it looks like under the hood. You're creating a function called user creator, name score, and then this dot name equals name, this dot score equals score. You just have to use it in a constructor function inside of a class. But that's really what it's doing, is just the same thing we're doing on the left, what we were just doing. Now, inside of a class, you may have, it looks weird because there's no function declaration, but you see this floating increment, this floating login. Well, what it's doing under the hood is user creator, it's adding these methods onto the prototype object on the user creator function. So you're doing it in fewer lines. It may look a little cleaner, but people under the hood, it is no different than what we just did. You are still using the prototype object. You're still using prototypal inheritance. It looks like classes, but this is not the same way under the hood that Java does it. It's just different in its approach and methodology. It just looks the same, okay? But there's no difference. So I will say, though, that this is definitely, at this point, way more popular than using just .prototype. So you'll see this way more often, but under the hood, no different than what we just went over. The last little piece I want to explain to you is when you declare a class or a function that needs to be invoked using the new keyword, because you've written it where you're using, this dot name equals name or this dot score equals score, you're relying on the new keyword to do those 4 steps. It is accepted that what you do is you capitalize the first letter of your function or your class, which is very different than what we normally, because in JavaScript we use camel casing, right? The first letter is under lowercase, and then the first letter of subsequent words in that variable declaration are capitalized. But if you ever see a function or a class, right, it's capitalized like this, the first letter is capitalized, it's just telling JavaScript developers you should use the new keyword when you're invoking this function. That's how we let other JavaScript developers know. Now, you don't have to. I mean, this could be lowercase, and you can still use new, it would work. This is for between developers. This has nothing to do with the JavaScript engine. Okay. So with that, people, this is the new standard. This is definitely the way you're going to do this moving forward. It feels like other languages like Python and Java, but I promise you, whereas 95% of JavaScript developers had no idea what the prototype chain was, 99% have no clue that if you write a class in JavaScript, you're just using the prototype chain. You're doing the exact same thing with solution 3. All right, everyone. Thank you so much. It is late for everyone, regardless of whatever coast or time zone you're in. So I appreciate you sticking around. Thank you so much. I hope to see you very soon. Have a wonderful, wonderful weekend. Bye, everybody.